Welcome to Maths for You channel. Another past question on limits, finding the limits. The question, show that the limit x tends to pi divided by 3, sine x minus pi over 3 divided by root of 3x minus root of pi equal 2 root of pi divided by 3. We need to prove that. So the left hand side is a limit. Let's start with that. The limit x tends to pi over 3, pi by 3, and the function sine x minus pi over 3 divided by the root of 3x minus root of pi. If you could substitute that value, x tends to x almost nearer to pi by 3, so x equal pi by 3. If you could apply that or substitute that value to numerator and denominator, see what we end up with. Sine pi by 3 minus pi by 3. So sine pi by 3, so pi by 3 minus pi by 3 is 0. Sine 0 is 0. And pi 3x equal pi. If you look at it, it's x equal pi over 3, so 3x equal pi. So the first part is pi for 3x minus pi. Again, minus pi, pi minus pi, root of pi minus root of pi is 0. So 0 over 0, it's an undefined result. So obviously that's not the way to deal with this question. So we need to do some some way to find it, some way to get the realistic value. And again, of course, the value is being given 2 pi root of pi over 3. So that's one method I use. I do not know whether all the A-level students use this method, but I just go through it, then another method as well. Right. So as I said, it's an undefined answer. When you substitute that value pi over 3 straight to x, then we need to find it. So there's another way, as I said. This way, it's done by L'Hopital's rule. It's a French name. I do not know whether I have the right pronunciation, but L'Hopital's rule. What that one says is the limit of x tends to p, f of x, so function of x numerator, g of x, another function of x denominator. If that's the case, that limit of x tends to p is same, but as equal to the differentiation of x, f of x, and divided by differentiation of g of x. So if that f of x to g of x doesn't work, that's what happened here, 0, 0. So we can use L'Hopital's rule, and we differentiate the numerator and differentiate the denominator, and the differentiation of numerator divided by differentiation of denominator, then substitute the value, see what we get. Right. So just I'm rewriting it. Limit of x tends to pi over 3, sine x minus pi over 3 divided by root of 3x minus root of pi. So the fx, the numerator, equals sine x minus pi over 3. So if you differentiate f dash x equal is cos x minus pi over 3, straightforward. And then the next one, gx, the denominator, the root of 3x minus root of pi. Then if you differentiate that, again, I sort of jump the step. So the differentiation of 3x is direct, I just wrote it directly. So 1 over 2 root of 3x, and then differentiation of 3x is 3, minus pi is a constant, so the differentiation of constant is 0. So what we left with is 3 over 2 root of 3x. Anyway, so it just use that values. The x tends to pi by 3, so x equal by 3. We have now the differentiation of the denominator. That is cos x minus pi over 3. So cos x minus pi over 3, then pi over 3 minus pi over 3 is 0, cos 0 is 1. So we have a value now for the denominator. The numerator, sorry, the value for the numerator. Now denominator, we know that g dash x. So again, x tends to pi by 3, that is x equal pi by 3. If we could substitute the value, 3 over 2, inside the root sign is 3 times pi over 3 x pi over 3. Then 3 cancel. You have root pi. So 3 over 2 root pi. So again, it's a meaningful value for the denominator. Now go to the full question. Limit of x tends to pi over 3. Sine x minus pi over 3 divided by the root of 3x minus root of pi. This one is the limit of x tends to pi over 3 for f dash x over f g dash x. That is the L'Hopital rule says. We have found f dash x when you substitute that x equal pi over 3 was 1, and the g dash x when x equal pi over 3, again we found it 3 over 2 root 3. So if you could simplify it, 2 root of pi will go to denominator, so 2 root pi over 3. So that is what we have been asked to prove. So that works out. But I just want to go through another method just to get rid of that L'Hopital rule, whether it's maybe it's sort of a degree level application. So it's just a simple way of doing this one. Right, method 2. Again, I'll write that question again. The limit of x tends to pi over 3. Sine x minus pi over 3 divided by the root of 3x minus root of pi. If we have this type of denominator, we can actually multiply numerator and denominator with its conjugate. So multiply top and bottom by conjugate. The conjugate is just purely the sign in between will change. If it's plus, minus, minus, plus. So is the root of 3x minus root of pi. The conjugate of that is root of 3x plus root of pi. So that's the conjugate. So just multiply top and bottom by the conjugate of root of 3x. So root of 3x minus pi. So the conjugate of root of 3x minus pi, that is it's 3x, the root of 3x plus root of pi. So all we are doing it, simply keep the function as sine as x minus pi over 3 divided by x root of 3x minus root of pi, then times, of course we have to multiply top and bottom to make this function same. So root of 3x plus root of pi divided by root of 3x plus root of pi. Just keep the top part same, so the numerator same. But the denominator, if you could look at it, it's like a minus b times a plus b. So the root of 3x is a, root of pi is b. So a minus b times a plus b. Then it's simply, we know that a minus b times a plus b is a squared minus b squared. So 3x squared is 3x. Pi root of pi squared is pi. So that is right. Let's do it further. Limit of x tends to pi over 3. Then I take that 3 out, the denominator, the 3 in the denominator, 3x minus pi. Purposely, I just take that 3 out. You will come to know why I did it. So 1/3, the top one, the denominator, sine x minus pi over 3, divided by here x minus pi over 3. And times, of course, 3x plus pi, root of pi is still there. Right, if we look at it, sine x minus pi over 3 and x minus pi over 3. The x tends to pi over 3. That means x minus pi by 3 tends to 0. or very small. So the x minus pi over 3 is so small. If that's the case, sine, that's a format here. Here, just when x tends to pi over 3, x minus pi over 3 tends to 0. It's very small, right? That's the trigonometric identity we should know. We know the limit of theta tends to 0, sine theta over theta equal 1, providing theta is small. Theta is small, very small. Theta, very small. And then, of course, the theta has to be in radians. So limit of theta tends to 0, sine theta over theta equal 1, providing theta is very small. So we know this x minus pi over 3 is very small. It almost tends to 0. Yeah. So sine x minus pi over 3. And again, we have x minus pi over 3. That is why I took 3 out before. So this part is just 1 because of the trigonometric identity. Now we are getting to close the question. Right, rewrite it. Limit of x tends to pi over 3. I took 3 out before, so 1/3 times, again, we proved that this part is sine x minus pi over 3 over sine, pi over 3 over x minus pi over 3, when x minus pi over 3 tends to 0 is 1, so it's 1. Then 3x, which we have 3x plus root of the root 3x plus root pi. Again, now we can substitute x equal pi over 3. It's x equal pi over 3, 3x, of course, pi. Right, now rewrite it again. So that's limit gone. So we're going to substitute the value. 1/3 times 1 instead of 3x, because of pi, x equals pi over 3. So 3x equal pi. Pi plus pi and plus root pi is 2 root pi. That's 2 root pi. So 2 root pi over 3. That's the answer. This is the A-level level way of proving it. The first part is, I believe, that's sort of a first year degree level proof. So just ignore it if you're an A-level student. Just stick with the method 2. That's the acceptable way for A-level students. Thank you. Please subscribe the channel and select auto notification. Thank you.